In this video, I'm going to make a random tree generator for my Minecraft style world. You can see the trees in the background. We're doing it all with code. We're going to do it similar to the terrain, right? You could change the cluster frequency, the cluster size, the height of the tree, things like that. We only have one type of tree, but once you see how it's done, you could easily add more trees. And of course, since this is for our Minecraft style world, we could go ahead and mine the wood in the tree. Right, and I don't have it fall down like in Minecraft, but you could easily add that. We got the basics of it. The leaves too. And I am actually going to store the leaves. I know in Minecraft you just kind of chuck them aside. Let's go ahead and get started with our random tree generator. Because we're leveraging off of the last video in my playlist, which was like the 7th video, you might not be following along, but you might want to make random trees. I will put this link in the description. You can come to this website right here, the URL, hit the 3 dots, hit edit in studio. You'll get a copy of the game and then you can follow along exactly. Now I have to make this world R6 because my animations are R6 and they won't work unless I do that. So let's go to avatar. We'll go to this button right here, the avatar settings. Go to these 3 dots, hit R6 only, and then save changes. Yep, we got to save and restart. That's all right. Nobody should be playing yet. And I'm just going to close this window. Now, if you don't have your own animations, you can go back a couple videos and build them. They're not that hard, but you have to publish the animation ID under your account for it to work. So if he's just standing there with a pickaxe, that's what happened. But you certainly don't need the animations in order to generate the trees or even to mine the trees, right? It's just that for the little axe swing, for the little pickaxe swing. Now I'm going to do the mining stuff at the end. I am going to work on the tree generator now. So let's go to server script service and you will see terrain manager. I actually have the script open, but if you can't find it, there it is. Double click, scroll to the top. Yours will probably default by opening to the top. And here's where all of our constants and variables are defined. I'm going to go down a little ways. I'm going to go above the blocks folder. And I'm going to add a few variables and constants. The first one is going to be a constant for the tree seed for the random number generator. So I'll say tree seed, and I'll just make this like, I don't know, 2, 4, 6, 8. If you want different tree patterns, just change the tree seed, play around with it. And now I'm not going to use the Roblox random number generator because we're using the Perlin noise. So I think I'm going to stay consistent and just use the math random number generator. And I will set the random seed and it's going to be the tree seed. Now let's add 2 variables for our tree clusters, right? So do local tree cluster frequency. So I'll make that one 0.04. Let's put a little comment because it's not easy to remember these. I'm going to say lower value equals bigger clusters. Bigger clusters. And then I'm going to do another one for how rare or how often the clusters appear. So that will be tree cluster threshold. Right. And that one, in the demo, I had 0.25, so let's stick with that. Here, higher is rarer clusters. I'm going to define 4 more constants for our tree placement, right? So individual trees. Let's do local tree min spacing, right? And that's, we'll make that, how about 3, maybe 4. I think 4 I did in the video, in the demo, right? And then let's do a tree height, right? We'll say height min. We'll say 3 studs high. And that's going to be the trunk. And then we'll do tree height max. Guess I could have copied and pasted that one. Let's say 8 studs high. And then we're going to need the edge buffer near the end of the world, right? So we don't get like trees kind of going off the edge or whatever. Or maybe you don't want it right on the edge. How about we'll just do 2. Now here's the tricky part. We have to think of a way to say, hey, we could put a tree on here. Like we're not going to put a tree on a rock and maybe not on sand. I'm going to put them only on grass. So I come up with this idea. I'm going to say local. I'm going to make a map. I'm going to say top block by XZ, right? And then that's going to be a table of tables. It's empty right now, but let's put a note in there. We're going to make the key the X and the Z, and then that's going to point to a subtable with the top Y value. That's going to be the height. So that'll be a number. And then a block key for the actual part, the instance of whether it's a piece of grass or a piece of rock. And then we're also just going to store the block type as a string, so we don't have to look it up. I think I'm going to move this. I'm going to cut that, Control X. I'm going to put it right above. Yeah, that'll work. And I'm going to do another table. I'm going to use that for the reserve slots around a tree, right? Because we have this spacing thing that we got to worry about. We don't want to put trees right next to each other. So how about we do local reserve XZ? So we're going to reserve the spaces directly beside the trees that are already been planted, right? Oh, and that one, should we put a little note there too? Maybe I'll put that here. So that one, the key is also going to be X and Z, right? But it's going to equal either a true or a false. True or false. So is it reserved or not reserved? And then finally, let's go ahead and make some constants for our canopies, right? So we'll say local, how about the canopy radius cells? Like how far across? And I'm going to say 3. That's what, 12 studs, right? Because each block is 4. So let's do 3. Let's try that out. I think that's what I had in the demo. And then we'll do another one for leaf density. Leaf density. I think I'll go 40% with that. Now, since we're building trees in a world that's already been formed, and the trees could interfere with other trees, like at least in the canopies, we're going to need to do the get part bounds in box stuff. We did that a few videos ago. In particular, what I want to do up in the top is get some overlap parameters. I'm going to do a Control F to do a search. I'm going to look for the overlap parameters that we did a few videos ago. How about oh, there we go. Overlap parameters. And then we define them. We have this tolerance, and then we check to see if we're touching anything inside the box, right? I think I'm going to leave it here for now, but we are going to clean this up. And then when we're doing our canopy and our trunks, we're going to use a common definition of this, right? We're going to do a function by itself. Let's do a Control C to copy these parameters first, and then we'll make a function with this stuff. Let's go back up. Oh, can we go back up here? I'm just going to hit this. I'm going to go all the way up like that. And right here at about line 65, I'm going to do a Control V. I'm not going to call it just parms. I'm going to call it, how about blocks overlap params. Right, then we know what it is. So let's copy that. Control C, change that. Control V, Control V. And what should happen, even though the blocks folder is empty right now while we're defining this, this is a pass by reference, which means if you put more stuff in the blocks, when you go to use the params, this should be updated. So when we go to do checks to see if there's something in the way of a block we're putting someplace, we're only going to include things in the blocks folder. All right, so let's move down here. I think I'm going to tighten my code up a little more. I'm going to do a constant for, how about touch tolerance, right? TOL. And I'm going to get my block size, and I'm going to subtract 0.2 from it. So we're not really going to worry about the edge conditions too much. We're going to check a little bit smaller than what our block size is. You'll see how it's done. I'm going to do it right here, actually. We'll do a touch box will be a vector 3 new. We'll do our touch tolerance. There it is. On the X, a touch tolerance on the Y, and a touch tolerance on the Z. Right? So we're making our box that we're checking just slightly smaller than a normal box. So now I'm going to go and find these overlap parameters. I'm going to delete what I don't need. Control F. Oh, it took me right down there, right? So we are in block place RE. So we're going to come down here. We can get rid of this, right? Ooh, and we can also get rid of this because we have the tolerance defined up above. And I'm going to put this in a function. Let's do that now. Let's do a control X, right? And then I have some stuff that's like is coal, is sand, and things like that. These check functions. I'm going to do a control F and then do is coal. Yeah, this is a good place to put it. I think I'll scroll down a little bit. Oh, above make block. Let's do that. Let's do a control V. And I want to put this in its own function. I'm going to say, how about local function is touching box. I'm going to pass in a center POS, right? A center position, and then a box size. I'm going to make that lowercase. Box size. Camel case, right? Now let's go ahead and hit the enter. Puts the end there. We will put this in the middle. Control X, Control V. That's looking good. Let's move this down. Do we need that? What should we change? All right, so right here we have our params. Remember, we changed those. So maybe we'll do our, block overlap params right there. Well, this is the box size. We actually make the box right here, right? So we'll make that box size, save some computation because we just make it once. Oh, and then for our center position, Control C. Oh, you know what? We don't even need to pass in the box size. Let's get rid of this. We have that touch box. Save even more on code. There we go. Touch box. Cool. So we got our center position, touch box, and the parameters. Now, what we need to do is check to see if there's anything in this table so we'll know if we're touching things or not. So we can say, how about, I'm just going to return the Boolean expression. I'm going to get the touching table. Let's look at the first element. If the first element is not nil, let's see, not equal to nil, then we are touching something. If it is nil, that's good. Then we know that we can put something there. So now let's go ahead and find where there's an if statement for that, right? So let's do a control F to find that touching table down below. There we go. Little search. This one right here, right? Down by about, 394. Instead of checking if the number of items in the touching table is greater than 0, well, that's all gone, right? We're going to do this. Let's do is touching box. And I think we got this new position right here, right? Control C, just plop that right in there. And if it's true, don't make a block because we're touching something. But if this is false, then we're going to continue down and make our block. Let's go ahead and try this out. Make sure we didn't mess up any of our old code. We'll hit the play. Takes a little bit to start because we've got to build the whole world, right? And then I'm going to jump on down here. Get our pickaxe. There we go. And now come on over here. Get our grass and see. Ooh, let's do this. Output window. Make sure there's no errors. See if we place it. We don't at least get any errors, right? It's kind of hard to check because our code is working for where to place the block, so we don't really run into that problem. But we might with our trees. I think it is working. As long as we're not causing any errors, we can be kind of confident that we didn't do anything wrong. Let's go ahead and turn this off, get back to our code. I'm going to shut this down. And then terrain manager. Now, if this was a high-stakes game, you would really want to write unit tests to try every possible combination of what could happen, and then you push out the code when you're satisfied that it's working. But I think at our level, we are fine. I'm going to do a Control F because now, oops, I got to click, Control F. Now what I want to do is look for our block properties because we have different types of blocks. There we go, block properties. There's only 4 occurrences. Let's go upward with it. Sweet. There we go, block properties. Let's come down a little bit. Let's add a couple properties. I'm going to copy my sand, right? Control C, and then Control V, Control V. One is going to be wood, right? And then for the material, we'll make that wood. And then I played around with some numbers that I kind of like. Let's do, how about 124? Does that look? And then we could do what, like 90 something? That's purple. Let's do this one. And 70. Yeah, that's the color. All right. I picked that off screen, so that's why I just kind of happened on it. I'm not really that good at colors. All right, and then I'm going to do a hardness of 8 for wood. Does that sound good? Leaves. We got leaves down here. Leaves. And this will make, how about leafy grass? Leafy grass for the material. And then these colors, I came up with 77, 130. So this is RGB, right? So a little more green in the middle. And then 72. Slightly different than the grass, so it doesn't look too strange. And then make that a hardness of 2. All right, so now we have to do a couple helper functions for our map to see where we could put trees. We're going to make a little map of the surface. I'm going to scroll down below my block properties, but above get equipped tool, as long as it's somewhere near the top of your code. Let's do a local function. How about an XZ key creator? I'm just going to call it XZ key. We're going to pass an X, we're going to pass in a Z, and now we are going to return the coordinate for the key, which is going to be toString, because that'll be a number, right? And then I'll do a string concatenator, comma delimit it, string concatenator, toString, Z. Basically, it's going to return this, right? It's going to look like this. This is going to be our key, X, Z. And that makes sense. This part right in here. Maybe I should go like that. That's going to be the key. That'll be good. It'll be unique and it's very map-like. So what else do I need? I need to keep track of my reserved areas. The reserved areas are the areas right around the tree. We created a buffer space. So I'm going to say local function, reserve area. Let me get that mouse out of the way. GX, GZ, and then we're going to set, we have our reserve table, right? XZ key. We're going to pass the GX and the GZ in there. And then we'll say true. Ah, man, we found a reserved area. Let's tag it true. Now I'm going to make another helper function. I'm going to do a control F. And it's going to be similar to this is coal. Remember when we have the is coal stuff? Let's go ahead and search for it. Here it is. So we have is coal, is gravel. This is where we were making our globs, right? We were making our clusters of stuff. Here's our is touching box. I think right below is sand. I'm going to do this. I'm going to scroll up here. I'm going to copy is coal. I want to do that for a tree cluster. Control C to copy it. Come on down here. Control V. And now we got to change the name, right? So we'll say is tree cluster, but we're using the same mathematics. Is tree cluster. And we're going to get down here. It's not a coal blob, right? It's a tree cluster frequency. How about that? Tree cluster frequency. And we're not using the Y. So look at this. I'm going to get rid of that. Let's go down here. The second argument will be the Z, and then we'll do a seed in here. Let's go ahead and, I want to get confused here. Control C, Control V, and then we're going to do the tree seed for the third argument. And that should work. Oh, but for the return, this Boolean right here, let's make sure this N that we get is actually greater than the tree cluster threshold. That one. All right, now let's go down a little more. I'll put it right below this. Is tree cluster. Let's do a local function is reserved for tree. All right, remember we did that little helper function up there. Well, now we're going to get our GX and our GZ, and we're going to go around the tree as much as we have defined, right? We have our min tree spacing. We will do a dx, which is the delta of x, the change in x around our tree. Let me move my mouse. And that's going to be a negative tree min spacing to a positive tree min spacing, you know, plus the tree itself. You could do a 1 there, or you could leave it blank because it will default to 1 if you don't put a third value here. Let's just go ahead and copy this. Control C, Control V, and then this is going to be for the Z around it, right? And now for all of these deltas around the tree that we might place, let's go ahead and say if reserve XZ, open and close square bracket, we're going to get our key XZ key for our GX and the delta X for each of those. We're going to get our GZ and our DZ, and we're going to say, hey, if this is true, if it's reserved on this spot or anywhere right around it, let's go ahead and return true saying, hey, this is reserved, right? Now that we have our helper functions, let's go ahead and start implementing some of this. I'm going to scroll down a little bit. I got some extra spacing here. There we go. I'm going to get rid of that. Check out this make block. All right, I'm not going to do anything there, but when we create our terrain block down here, we call make block. And what I'm going to do is not only am I going to call it, I'm going to return it, right? Because, scroll down a little more, when we're doing our terrain loops and we create our block, if we capture that block, we could tell if it's the top block and what type of block it is, like if it's grass and stuff like that or sand. So I want to get that block. Right below that, I'm going to fill up my map. I'm going to say, I'm going to do my top block by XZ map. I'm going to say if Y equals top Y, and let's check to make sure the block exists. Then let's do our top block by XZ square bracket XZ key. We're going to pass in the X and the Z. And then we're going to create a little table. That's what we're going to populate that element in our top block by XZ with. We'll say, how about the top Y? We need to know where the height is when we build our tree, right? So that's going to be the key, and this is going to be the value. We have a top Y right here, right? So that'll work. And then make a key called block, and it's going to be this block, right? This is going to be the value. Whoops, I spelled it wrong. And then what else do we need? Just for convenience, let's put our block type in there. We'll say block type, that's the key. And if you spell it wrong here, just remember in the code later on, you're going to have to match that key. So probably get it right. Then we're going to get our block and we'll do our get attribute. I think this is just more convenient that way, right? Get attribute. And what do we call our attributes? It's like block type, but with capital. All right, let's go ahead and scroll down a little more. I'll put my tree stuff, my placement stuff here. So I'm going to give a few spaces, maybe scroll up a little bit so I have more room to code. And I'm going to have a function, we'll say local function for place leaf cluster. For the leaf cluster, I'm going to need the GX, the GZ, the base top Y, the trunk height, right? We don't have those yet, but we're going to get them soon. Trunk height, and then the base position, the base POS. All right, we got those here. Let me put this on the next line so you guys can see it. You can keep it all on one line if you want, though. And I'm just going to put that there for a placeholder. And then I'm also going to need a function, place, tree, trunk, at, and then we're just going to need the GX and the GZ. We'll get back to these two functions in a second, but I'd like to get my loop that places the trees first so we could do some testing, because there's probably some errors in our code, but hopefully not. But let's start doing a little testing as we go. So I'm going to go for X equals 1 plus, remember we're going to do that tree edge buffer so we don't have trees right along the edge of our world. And then we're going to get the terrain width. Right, and then subtract the tree edge buffer. That's the other side, right? We're going to go through the terrain along the X. You could put a 1 here, but it defaults to 1 if you put nothing there. So I'm just going to leave nothing there. And then we're going to do the same thing for our Z, right? We go here. This is going to be a Z. And then this is going to be depth, right? So the depth, sweet. And the edge buffers are the same. That's good. And then we'll just call our place tree trunk. And in place tree trunk, we're going to pass in our X and our Z. And then place tree trunk is going to call our clusters. All right, so now let's go up to here and start putting stuff in this function, and we could test as we go. So the first thing we're going to have is our top block by xz. Get all the top blocks, right? So we'll say local info equals top block by xz. We're going to use the square brackets. Then we're going to use the xz key, right, with our gx and gz. Do a little check to see if our info is good. We'll say if not info, or not info dot block, right? We want the block there too, or info dot block, and let's check the parent too, just make sure it's parented and everything. Make sure that info dot block parent equals nil, right? That would be the bad thing. Then, well, you could do a print statement here. You know, print if needed, if you're doing troubleshooting, right? And if not, what we'll do is we'll return false, right? We had a little bit of a problem. So we're not going to continue by placing the tree. And what else should we do? Let's check if info, let's say info dot block type. Oh, and we used a little b for the key. So we'll say block type does not equal grass. We're going to bail out, right? So we'll say grass. We're only going to put trees on grass, but you could put trees on other things if you want. This is how it's done. So what we could do here, should we put a print statement? We could try, right? We could print all the sand out, right? We'll say not grass. You want to take that out though, because it does really add to the cycles on startup. It's going to slow things down, but it's a good troubleshooting thing. So we'll say not, oh, we can just do not grass. Oh, you know what we can do? Block type. Just put the block type in there. Wait. We should just have sand in here, right? And then we're also we're gonna bail, right? So if it's not grass, we're gonna return false, right? So it didn't work out, boom, return false. Didn't work out, boom, return false. Let's go ahead and try it out. See what we got. We should get a whole bunch of sand, no errors in our output window, but a whole bunch of sand messages. This is gonna take longer starting up. Oh yeah, gravel too, right? We have some gravel. I forgot about that, but grass didn't print out. That's fine. Oop, not grass, gravel. Cool. Looking good. All right, no scary red stuff for errors. We know our map is at least working a little bit. We can go ahead and get rid of that print statement, or you can comment it out if you think you might need it later. All right, we're going to get the base position where we're going to put our tree trunk. So I'm going to say local base POS equals all of this info block. Remember, that's actually the instance, which means we have a position of our block. And now we should check some spacing, right? Let's go down a little bit more. So I'll say if is reserved for tree GX and GZ. Well, if that happens, then let's return false. I think I'll just put it all in one line. It's getting, our code's getting long. Cool. What else should we check? So we have the reserve. How about if not is tree cluster, right? We have to do our Perlin noise probability, GX, GZ, then return false. And nice. We're getting a lot of stuff here. And let's get our height now, right? We're going to randomize the height of our trunks. So we'll say local, how about H equals math.random. Remember, I'm not using the Roblox random just because I want to stay consistent with the math library. And then we'll do the tree, what's it? Tree height min to tree height max. Oops, let's see, get a couple more letters in here. Tree height max. That's what we need. So it's going to return, it's actually going to return a number, not an integer, but we have blocks. So we're going to have to deal with that. It's not going to be that bad though. We're going to take care of that by using this for loop. We're going to say for I equals 1 to H, and it's only going to go up to the integer, right? We're going to do, how about do steps of 1, right? And then we'll say local POS equals base POS plus, we got to move it up a little bit. We can't put it like right on the grass. We have to say, we'll keep it at the same X, I times block size, right? It's our I for our height. And then we're going to keep it on the same Z. Ooh, and we have to do our if is touching, right? If is touching box. Check to make sure there's nothing in there before we put our trunk block. And then we don't have to put our trunk box in there. I'm going to check that real quick though. And we'll say then, if it is, return false, right? If it's touching, return false. If it's not, we'll just keep going down here. So basically right here, we're not really putting the wood stuff. We're just checking to see if we can in every spot. If not, then we'll bail out. You know what I'm going to do? I'm going to cheat a little bit. I'm going to grab this because I'm going to do something really, really similar. I want to check the entire path of the trunk first, and then I'm going to loop again. We'll do some other stuff here. Let's save that. We're going to need that, right? We're not going to need this. We are going to need a Y. Let's do that. Local, how about NGY? Right, and we're going to say info. And we have our top Y that we saved plus I, right? And then our position, we could keep that the same. And then make block, let's do that. Make block, wood, POS, GX, and then NGY for the height, and then GZ. Should we test it? Yeah, let's test it. Let's hit the play button. Window. Oh, I don't see any trees. What's this? Attempt to perform arithmetic mole on nil and number. Click. Ooh, I see. So I'm going to turn this off. I'm going to go here and then let's check. Control F. See where we're calling it. Oh, yeah. Check that out. I'm only passing in an X and a Z. Let's go back. And there we go. I just hit that little button right there to go back. We are not going to need the Y. All right, do it again. I guess I could have left that window open. Hold on. Window, output. Boom. Look at that. We got trunks everywhere. Oh, that's because we got to put the reserve space. But we have no errors. That's pretty cool. And we got some trunks. All right, let's turn this off. Yeah, we just close this window. I'm going to go back to my terrain manager. I'm just going to do a search to go back to where we were at with our place trunk at tree. Let's get down here. We make our block. If we get all the way down here, let's go ahead and add our reserved area, right? So we'll say reserve X, not XZ, reserve area, GX and GZ. You know what else? Since we're going to do this and we did define the skeleton function, we're going to put our leaf cluster here too. In there, we're going to put our GX, GZ, info.topY, our H, the height, because we're going to go up to the top of the trunk, and that's where we're going to put our cluster, and then we'll have our base position. All right, let's try it now. We should have better trunk placement. That's pretty good. Yeah. All right, and that should look very similar to the one in the demo because I used the same seed. All right, I'm liking it. We just have to do our leaf clusters now. Let's turn this off. Go back to our terrain manager. So place leaf cluster is the last piece of our code. Let's finish it off. I'm going to scroll up a little bit. There it is. How about that? Place leaf cluster. First thing I'm going to do is I'm going to define a local variable. I'm going to call it R cells. So it's the radius in cells, and we have that as a constant up top, but that's really long to type. I want to be able to type this more and faster, especially for the video. I'm also going to need a few variables to center the canopy slightly above the trunk. So I'm going to say local, how about center Y equals base top Y plus the trunk height, right? And then add 1 plus 1. Let's do our center position, center POS. We're going to get the base position, right? And it will say plus vector 3 new. We're not going to change the X here. We are going to go trunk height. There we go, plus 1. And then let's do this. I got to multiply it by the block size. So I'm going to put this in a parenthesis. I'm going to add another parenthesis here. I'm going to say, right here, I'm going to say times block size, right? And then for our Z, I'm just going to make that 0. We don't need anything there. I'll get rid of that extra space. Whoops. Oh, I hit the insert. Get rid of that extra space. I think we'll move this on the next line, just so you can all see it, right? You can keep it all on one line. Now here we're going to do 3 for loops for the canopy sphere, or, close to the sphere as you can make with blocks. I'm going to do a for loop for our change in X throughout the sphere. We'll say dx equals negative r cells to r cells, right? From the negative radius to the positive radius. And then you could do a 1 here, or we don't have to. We could do the default of 1 because it'll default to that if you don't specify it. Let's go ahead and copy this. So that's for our X. We are going to do one for dy. Oops, I don't need that. There we go. I did a paste. And then I'm going to need another one for dz. There we go. Now, if you guys are pretty good at geometry, you might be thinking, hey, that's a cube. That's not a sphere. So I'm going to put another check just so that you can make a sphere. You might want cubes. Just leave this if statement out. But we'll say if vector 3 new, we'll go dx, dy, dz dot magnitude. We're going to go the vector out from the center to make sure it's less than or equal to r cells. And this will get rid of the corners in our cube, right? Making it more spherical. But if you're fine with like block canopies, that's you don't have to put this if statement in. So let's do this. Let's say if not, whoops, that's a new. If not dx equals 0. I'll explain this in a second if you're not following. dz equals 0 and dy less than or equal to 0, then this is, hey, if we're below and running into the trunk, let's not try to place the leaf cluster. It's just a little extra computation that we don't need. Now we have our leaf canopy density defined up above, so we're not going to have a solid block of leaves. We can adjust the density. I'm going to use the math random, right? And then I'll say if it's less than our leaf density, then let's place the block, else we're just going to skip over it. So our leaf density is like, I think it's 0.4, right? Which is a random from 0 to 1. So 40% of the time we're going to put a leaf block. Now I'm going to need some new gx, gy, and gz derived from our gx plus the delta x, right? The delta x being off from the center of our cluster. Let's do a local ngy, and that's center y. Remember we calculated that up above, plus the delta y, right? dy. Did I get that right? There we go. Let me roll this up a little bit. And then we need our ngz, right? And that's just going to be the gz plus the dz. Now let's find the center of our cluster, of our leaf cluster in block coordinates, right? So the 4x4 coordinate system. Let's do local POS equals, well, we got our center position. That's good. And then we're going to add a vector 3 new. And let me see if I can hit an enter here. I'm going to fill it in down here. We're going to have our dx times block size. We're going to have our dy times block size. And our dz times block size. There we go. Scroll down a little more. What are we going to do with that position? Well, let's do an if not. Let's do a check. If not, touching box. Right? We don't want to put a leaf cluster if something's already in the way. Like maybe a neighboring tree might have a leaf in the way or something like that. We'll just pass in our, whoops, that's a pox. How about a POS? A POS, then we'll make block. So if not is touching, let's make block. We're going to say leaves, right? That's going to be our block type. Pass in our POS. We're going to get our NGX, NGY, and NGN. Oh my goodness. NG, I'm losing it. Z. Looking good. That's a little bit long though. You want to just split this up a little bit? There we go. I don't know if that makes it any better. Oh my gosh, look at all these ends. Do you think we did that without making a mistake? Let's try it. Let's try it. Hit the play button. Window. Output. It's looking pretty good. Yeah. I think we got it, right? And if you want it to be a little fuller, you can increase your canopy density if you want it a little less. Now, we can't collect the blocks yet, right? You can mine the block, but you can't collect the block. I think I'll collect the block for the wood. I don't think I'll do leaf, but you do leaf the same way as wood if you want. All right, so let's go ahead and turn this off. We'll go get rid of that output window. I want to go to the player manager first because we're keeping track of the things that we mine and we want to show up in our backpack. So we can make our, how about wood? Let's do a Control C, Control V. I want to make this wood. All right, we'll go wood, and then don't forget to change the name. That should work. Oh, and we have to make a tool for the wood too. And I don't remember the color. I'm going to go back to the terrain manager right here, right? Or you could do it here too. Right, I'm going to scroll up under block properties. I need to get that color. Here's our block properties. Wood, and I have wood and leaves, so you could do this with the leaves too. I'm just going to do it for the wood though. So I'll do a Control C, and then I'm going to go to server storage. Here we go. I'm going to grab the stone. I'm going to do a duplicate by doing what? Control D. There we go. And I'm just going to call this wood. Sweet. I'm going to open that up. Look at our handle. And then instead of silver, I'm going to put that 24 or 124, 92, and 70 in place. I'll just do a Control V. There we go. So it's going to be that color of wood. I wanted it to match. And let's take a look at our, what's it, material. Material, instead of slate, obviously wood. We even have it. Cool. Let's see what that looks like. So I'm going to hit play. And you could do the same for the leaf if you want to collect leaves. I think I'm just not going to collect leaves though. Get our stone pickaxe. Cool. Now we got a piece of wood. Let's say we want to build with it. I'm going to put it right there. All right. Now the leaf will disappear, but we're not collecting it. You'd have to make a tool for it, and then you would have to put that in the player manager if you wanted to collect leaves also. All right. So I think that's working pretty good. I will see you in the next video.